Okay, I want to look at one more example of linear motion. In this case, we're going to look at an object undergoing free fall motion, essentially a projectile, and looking at its height above ground. So neglecting wind resistance, the height s above ground of a projectile t seconds after motion ensues is given by this equation here. And in Calculus 2 you can actually derive this. So it's negative 16t squared plus v with a subscript 0. This is v sub 0 or v naught. That's the projectile's initial velocity in feet per second. Keep in mind, velocity here, we're talking about s being its height, right? That's just up or down. And so when we talk about velocity, positive velocity means we're moving up, negative velocity means we're moving down. S sub 0 or S naught is the projectile's initial height above ground in feet, okay, in feet. And the negative 16, some of you know, has to do with the acceleration due to gravity. It's actually equal to 1/2 the acceleration due to gravity. The negative sign has to do with the direction of that force. So let's take a look. Giving you this formula then, let's see if we can answer these questions. So a projectile is launched upward from a 100-foot tall building at an initial speed or velocity of 256 feet per second. I should probably actually say initial velocity, because velocity could be positive or negative. Here it's positive, so in other words we're launching it upward. Okay. So what is the height s above ground of this projectile t seconds after launch? I guess I could say speed since I said launched upward. Okay. So what is this height s? Well, we've got the formula right up here. It's negative 16t squared. What's the initial velocity? That's this thing right here, right? This thing right here tells me that v sub 0 is positive 256, right, feet per second. So plus 256t, right, plus the initial height. What's the height? So since we're launching it from a 100-foot tall building, we're going to let ground level be 0, so our initial height will be 100 feet. S sub 0 is 100, and so there's my formula. Okay. What's the velocity and acceleration of the particle t seconds after launch? Well, the velocity, as we know, is the rate of change of the position, in this, or the height in this case. So what is the derivative of this polynomial function? Pretty easy to do. Bring the 2 down. I get negative 32t plus derivative of 256t is 256. Of course, what are the units? Feet per second, right? Dependent variable units, this function outputs feet given the corresponding time in seconds. Acceleration is what? The rate of change of velocity with respect to time. Again, same as the second derivative with respect to time. So we just take the derivative of this and I get exactly negative 32 feet per second, or feet per second squared. Okay. And some of you know that's the acceleration due to gravity, 32 feet per second squared. So acting in the negative direction, right? Trying to bring the projectile back to Earth, accelerate it towards Earth. So what's the projectile's maximum height? Well, think about it. The projectile launches with a velocity of positive 256. It's going up, right? What's happening to that velocity as it moves up? Since the acceleration is always negative, it's slowing down, right? The velocity is getting smaller, closer and closer to what? 0. What happens after 0? Then the velocity, the object starts coming down, its velocity is negative, right? So velocity positive going up, velocity negative going down, and it's speeding up as it goes back to the Earth. So notice the projectile's maximum height is when its velocity is 0. Okay, and that's the way I want you to solve this using calculus. Some of you recognize this as a parabola, and you remember how to find the vertex of a parabola and find the maximum value. But we're going to use calculus because that'll be important later on as well. And so it's important to realize it's when the velocity, or what, the derivative, the rate of change of the position with respect to time, when that is 0. And so I'm solving this equation. The velocity we said was negative 32t plus 256 right up here. Set that equal to 0 and solve. Right. Pretty easy linear equation to solve. Subtract 256, divide by negative 32, 32 there. Divide by negative 32. Negative divided by negative is positive. I get 256 divided by 32, which comes out quite nicely to 8. I think I contrived this problem to work out nicely. So 8, what are the units again? T is in seconds. Okay, that's not the answer to the question, what is the projectile's maximum height, but that tells us when that occurs. So how am I now going to find the project's maximum, the projectile's maximum height now? I want its height s at what? 8 seconds. That's when the velocity is 0. That's when it's going to reach its peak before the velocity becomes negative and it comes back down. So I go back to the original function here and plug in negative 16 times 8 squared plus 256 times 8 plus 100. And if you do that math, check and see, you get 1,124 units or feet. Right. So there's the projectile's maximum height, and we'll reach an altitude of 1,124 feet, according to this model. Okay. How long before the projectile hits the ground below? Remember, the ground is 100 feet below the launch, right? So what do we want to do? We want to find the time, t, right, how long, such that, what is our height above ground? S of t is what? 0. We want to be on the ground, we want t to be 0, or s to be 0. So S of t, if you remember, is up here. We want to know when this output is 0. So again, we're going to solve this quadratic equation. Here, if I try and factor, I solved the quadratic equation in the last video. Here, if I factor out a negative 4, whoops, negative 4 means this is negative 64t, and this is negative 25. Okay. Now, how would I solve this? Well, I can solve this not by factoring, but I'm going to solve it by the quadratic formula. Right. So t is, if you remember, negative b, which is minus a negative 64, positive 64, plus or minus b squared, so negative 64 all squared, which is going to be a positive number, minus 4, a is 4, c is negative 25, so this will be plus some big number, all over 2a, and a is 4. Okay, so I factor out the negative 4. This is 0 when t is this number, and so I'm not going to do all the way through here, but this is 64 plus or minus, if I square 64, I'm just going to do this calculation, right, square 64, same as squaring negative 64, and then minus 4 times 25, that's 16 times 25, negative times negative, it's plus 16 times 25. So I get 4496. 2 times 4 is 8. Now notice when I evaluate this, so 1 is going to be 64 plus the square root of 4496. Put that all in the numerator, divided by 8, right? If I evaluate that, I get 16.4 about. The other one would be minus, okay? Of course, that root is a negative number, and so remember the time, we're starting at time is 0, so right? The negative answer doesn't make sense. Time has to be greater than 0. And so we're going to only use the, so there's two roots here. We're going to use only use positive root. And so we get t is about, what do we say, 16 point, we'll just round off 16.4 seconds. 16.38, whatever, 16.4 seconds. Okay. So that's a pre-calculus question, by the way. There's no calculus there. But now, what's the projectile speed on impact? Okay, well now that essentially is a calculus question because the speed was determined by calculus. What was the speed? What's the velocity? We'll talk about the difference. What is the difference between velocity and speed? I want to clarify that here in just a minute. But the velocity we know we got from the derivative is the rate of change of positions, negative 32t plus 256. So if I plug in this time into the velocity, this time is when it hits the ground, then we'll get the velocity on impact. So v of 16.4. So about, right? We're using that approximation. So negative 32 times 16.4 plus 256. So I'm just plugging it back into the negative 32t plus 256, letting t be equal to 16.4. And if you do that, you get negative 268.8 feet per second. Now, what's the negative mean here? We're going down. Remember, positive velocity up, negative velocity down. So what is the speed? When we talk about speed, what's the difference? Speed is always the absolute value of velocity. And so the speed is just 268.8 feet per second. Okay. But essentially, the negative sign of velocity has a sign, right, associated with it. So velocity has the direction as well, whether we're going up or down, right? When we ask for the speed on impact, though, we obviously know we're going down, and so you would just want to give the actual speed. 268.8 feet per second was how fast the projectile was going when it impacted the ground below. Okay, so you've probably solved problems of this nature in pre-calculus because the function here is a parabola, and you can determine the vertex of the parabola and get the information about the maximum height, for instance, and this is essentially what you can do here. But the velocity, in this problem is needed using the calculus. Okay, and we're going to do more of that in the future as we look at more applications. Okay, but that's sort of a brief overview of how we can use the derivative as a rate of change.